and today we will discuss about the natural agency, the work done by a natural agency, that is glaciers. So all of you must have heard the term glaciers. Glaciers are huge body of ice characterized by its downward or outward movement. So in a simple way, simple term, if you say, glaciers are large moving body of ice. And if you see the percentage of glaciers covering our surface land, which comes around 1/10 of it, the total land surface on the earth, which is covered by glaciers. And out of this 1/10, around 85 percentage is in the Antarctic continent, and 10 percentage which covers the Greenland and the polar regions of our earth. If if due to any reason, if all this ice, the glacier ice which is there in the Antarctic region, if it start melting and if the water is going to come to the seas and oceans or in the water regions, then at least the present day water level what we are getting today would be 65 meters above. So that is what the glaciers can do the surface of our earth. Okay, so what we are going to discuss about that, what these glaciers are doing in our surface of the earth, and what kind of erosion and depositional features which are producing, and how do we identify that. So this is the our Indian subcontinent, and if you see the glacier, so where we are right now, this is the part, the ice covered portions, if you see, and um, if you remember, if you heard the Siachen Glacier, what is the highest portion where the Indian military is occupied. So here we are getting the Siachen Glacier portion. So we are almost in the Siachen Glacier. So if I see these glacier portions, and this is a uh, general characteristics of the glacier portion. Okay, so you can see that how these things are moving, and if you zoom in, and if I see here, see that the large body of it, it flows like a river, but it is not river water. What is it? It is all ice. It is all ice which is covered on the surface, which is flowing towards the downslope direction, downward direction by the action of a gravity. So this is a glacier where we are in. So here you see there is another large body of moving ice which is flowing through this valley. Okay, so this kind of areas where the body of ice covered, so that becomes the glacier. So that is one glacier portion we have seen, and the other one, if you see, um, what is this part of our earth? So this part is our Antarctic region. That what was we were discussing about, the Antarctic region, which covers around 85% of the total ice or the glacier cover of the earth's surface. And if you go to the other portion, so this is our Greenland region. Okay, so all these areas which are this is completely covered by glacier mass. So this becomes a major. So this is what the basic criteria to classify this is glaciers. So there are basically two types. First one we call it as ice sheets or continental glaciers, which is that these are the ice or the sheets or the glaciers which are covering our polar regions and the Greenlands and Antarctic regions. So this is basically the large region. 85% is covered in the Antarctic region, and the 10% covers in the Greenland region, and the rest of the 5%, which is what we get all other parts in the mountain glaciers. So one example we have seen the Siachen Glacier, which is a mountain glacier, which is a Himalayan glacier. And if you see a general idea about how these glaciers are forming, the large amount of snowfalls is not forming in all parts, where it forms only in the areas where there is a snowfall and it slowly accumulates, and this finally accumulated snow which convert into a slightly compacted fern, so that finally converted into a glacier because of the continuous deposition of more snow and its own weight and the escaping of gases which is present in the air, which is present in the snowflakes. Okay, so this process actually produces glaciers. Now, as you know that all the natural agencies what you are discussing on, whatever the processes which are doing, that will have different activities doing on the surface. So we call it as the natural processes are geological work done by that particular agent. And here in this case, we are going to study about the geological work which is done by a glacier. So if you can guess that what are the geological works a glacier can do, it can erode, or it can transport, and it can deposit. So erosion, transportation, and deposition. So these are the three main geological processes which a glacier does. So we are going to see this one by one. First, let us see an erosion process. How do glacier erode? Because glacier is a large body of moving ice which is moving on the surface of the earth. While which is moving on the surface of this earth, this is a huge thickness of ice, and when it is in contact with the bedrock, because of the high pressure, some amount of glacier or the ice in this part will get melted, and that melt water will enter into the fractures or any small cavities which is present in the rocks. So that things which is entering into these cavities will pluck, that will pluck the rock type, and will be detaching from the surface of the rock. So that we call it as the glacial plucking. Once that it is plucked, it is going to be there in the ice, and this process of melting is only in the high pressure, which happens only in the contact, but in the above the contact, when it slightly moves up, it will again become an ice, and these things will be carried by the glacial. And these things which are carrying by the glacial, while moving this glacial towards the downslope direction, will be grinding the earth or the bedrock again. Bedrock, what I mean, it is the basement rock which is above this the glacier is moving. So it will be grinding. So only it is not only the water, the ice along with the small sediments. If you remember that, what is that process called? The agent, some agent along with the sediment grains which eroding the material, that process, that is called abrasion process, or that is called a glacial abrasion process. Okay, so these are the two main processes by which a glacial erosion is done. First one, it is a glacial plucking, through which the water which plucks the particles of the rock particles, and the second one, along with the plucked particles, the glacial will erode the other portion of the bedrock. So these are the two processes. As a result, when this kind of erosion processes are happening, and you have seen that the volume of ice or the glacial covered regions and the movement of glaciers, there are large amount of erosional processes which are going on the surface of the earth. So that kind of erosional processes will produce some erosional features. So what we are going to discuss right now, what are these different erosional features which are going to be produced by this erosion activity of the glacial. So if you see the first one, the erosion activity which is produced by the glacial is called a glacial striations. Glacial striation is nothing but when a glacial moving on the surface, the glacial only may not be able to produce a striation, but because of the large amount of rocks which are carrying by this glacial in the basement portion, will create some scratching on the surface of the rocks. So this scratching of the surface of the rocks, what is produced by the glacial and its carrying sediment, we call it as a glacial striation. So glacial striation is an indication of the direction of the glacial movement. Second one, it is called a whaleback forms. It is nothing but a large glacially eroded residual rock. So this part is actually now elevated, and it is a hillock type portion, and the glacial which was filling this valley, now it is gone, but this remaining, this rock belt, it's remaining. So this we call it as a whaleback forms. Third one, it is a crag and tails. It is nothing but when there is a glacier which moves to the direction, in case it encountered with a hard rock which is resisting the erosion process, As a result, this portion of the rock will be slightly less eroded, and as a result, further the rock which is soft and easy to erode will also remain on the backside of the crack. So this portion which is resisting rock, we call it as a crack portion, and the backside of the downward side of the crack which is preserving or which is saving some amount of soft rocks, which we call it as a tail portion. So crack and tails is indicated by the erosion process of a glacial. And then we have a glacier valley. Glacial valley is basically we call it as U-shaped valleys, because the valleys which are produced by a river, when it is filled with glaciers, when it is moving through the glaciers, it will be converting to a V-shaped valley to a U-shaped valley. So there are basically one type of glacial valley, we call it as hanging valley. So what is this hanging valley? For example, if you see in this case, here this is the main valley where the glacial is moving, but there are some valleys which are contributing, some tributaries which are contributing ice to this glacial, but the height of this is not at the same level of this main valley, which is slightly elevated. Why? Because the river, it is not like river. If it was in the case of river, we have seen there is a downcut activity, and this downward cutting of the valley will the valley will cut the valley, and it will downward cutting will immediately, or it will take some time, but it will convert this valley's depth into the same level of the main valley. So that we call it as a local base level of erosion. But in this case, that process doesn't happen. As a result, the tributary valley will be at a higher level compared to the main valley. So if I see some examples, if you see the same Himalayan region where there are so many tributaries which are contributing to this valley. So I have not traced anything right now, but if you browse on this, where somewhere we'll get a valley which will be comparatively in a higher level than that of the main valley. Okay. So here also, if you see, so this is a glacier which moves, and see that how it is coming. And if you see here, then one valley here, there is a valley. So see this valleys. This is typically like a river, because this valley, if you see, this is typically like a river. It is almost meeting the same level. But if you browse through here, you will find some valleys where the elevation would be much higher. So here, if you see this valley, okay, so this valley, the height is not reaching up to the base of the valley, and if this part of it is covered, so this will be continuously contributing meltwater or ice to the main valley, but this is not at the same level of the base level of the main valley. So this is, we call it as a hanging valley. This kind of major valleys, this kind of valleys, we call it as a hanging valley. So number of such hanging valleys will be seen in the glacial affected regions. Okay, so that is hanging valley, and the next feature, which is called as cirques. The cirques are steep-sided, half-bowl shaped. So this is because of the erosion activity of this one part of the glacial which continuously erodes, and this erosion which produces a bowl shaped depression in the valley side. So that we call it as a cirques. Fjords are highly overdeeping narrow valleys produced by the glacier is called fjords, and there are some few more terms like arete, horns, and cols. So these are all different erosional features. So this classification is basically based on that how the edge or the crust of this is appearing. The horns are if you speak about horns, that is something like a pyramid shape, the flat shaped. The surface or the top of this would be something like a flat shape, whereas the aretes are Arates are that sharp edges like a knife. Okay, so this is a horn where it is something like a pyramid type. It's all three sides. But if you see here, it is like a knife. The sharpness is like a knife. So that we call it as Arates. And coal is another geomorphological feature which is actually forms a depression between these two elevated surfaces. So that is a narrow depression forming, that is called a coal. So these are the basic erosional features produced by the glacier. After the erosional process, now what is the next process on a glacier system? That is the transportation process. So this is the process of glacial transportation. Glacial moves the material as a whole. It is not like a river, but this all complete body of the ice which moves, but the movement is in different velocity. If you see the bottom portion, that would be moving comparatively less speed, less velocity compared to the top portion because of the frictional forces which is acting from the bottom. Okay, so the material, how the glacier will move the materials? Glacier will move the materials which are present in the ice when the glacier moves. Okay, so when the glacier moves, along with that, the materials will also move within the glacier. So the based on the locations where these materials are moving, this glacial transportation processes are classified into three. First one, it is a subglacial loads, which are the load or the sediments or the large boulders which are carrying by the glacial in the bottom portion of the glacial. So along the contact between the glacier and the bedrock, so it moves. The second is called the inglacial loads, which are completely in the glacial, which is carrying within the glacial. So this is all present within the glacial. And there would be a third category of glacial load, which we call it as a superglacial loads, which are the materials or the sediments which are present above the glacier, which is above the glacier surface, or it's slightly beyond the embedded within the glacier surface. So while moving this, this will be moving. So what happens to this all three different varieties of loads? Subglacial loads, englacial loads, and the superglacial loads. Superglacial loads on the top of the glacier, subglacial loads on the bottom portion, and then glacial which is enclosed or embedded within the glacier. So what happens to these all glaciers materials which is transferring by this the glacial? This will be transported at the glacial will reach up to one point, then it start melting. So when it melts, the water will leave the glacial and all these materials will started depositing in some portion of the surface of the earth. So that process we call it as a depositional process of the glacial. So any sediment which is any sediment or the material which is deposited by the glacial, we call it as a drift. Okay, so any accumulation which is produced by a glacial deposit is called a drift, and drift is basically an unsorted group. Unsorted means there would not be any uniformity in the size of the grains. Sometimes it would be large, sometimes it would be small, because glacial doesn't have contradicting in the same way. If you see a river will carry only some particular amount of size in suspension, some particular amount of size in saltation, some particular size in dissolved. But that kind of things are not here in the case of glacial deposits. So it can take any sediment in suspension. It can take any sediment in the bottom load. Any type of sedimentation is possible. And when it deposits, also it doesn't follow any pattern. It simply deposits, and that will be a really unsorted deposition produced by a glacier. So there are basically three type of deposits, which is called the drift. These are all three different varieties of drift. First one is called a till. This is unstratified. There is a small spelling mistake. It's an unstratified drift, maybe loosely packed sediments depositing at the stage of a glacier. So this is again the stratified fill is something which is a joint action of fluvial deposits and the glacial deposits. Now, as I said, the fluvial, the glacials, which is reaching at the area where the ice started melting. As a result, what happens? The water will start flowing. So, at the end of the glacial, the process is a river or a fluvial process. So, that fluvial process will revert the sediments and it may produce some kind of stratified deposits. We call it as a stratified till. Till means it is originated by a unsorted glacial deposit, but it is stratified by probably may be due to a fluvial process. The third one, it is an erratics. Erratics is nothing but because when glacial carries the material from the top of the hill or anywhere, it is not having any control that what to carry. So we may get some kind of rock which is completely foreign to this region. Okay, this rock types what you are getting in the area where these things are, this is deposited, this rock type is deposited, this is completely foreign. There is no source in the nearby region. So this kind of deposits what we get, we call it as a erratics. Okay, so these are the main glacial deposits. Now this deposits of drift which happens in the glacial environment, that produce a number of different morphological features. Morphology means which forms some landforms, some hillocks or some depressions or some ridges. So that kind of morphology when it makes, that morphological features are number one, we call it as a moraines. Okay, so moraines is a glacial depositional feature produced by completely unsorted, unlayered debris. Debris means sediments. So whatever the grains or the rocks which are carrying by these glaciers, which will be coming, and some of the things will be depositing in the sides of the glacial, okay, or the middle of the glacial flow. We call it as a medial moraines. Some of the things will be depositing in the sides of the glacial, at the periphery of the glacial or the boundary of the glacial. We call it as a lateral moraines. Some of the things will be depositing at the end of the moraines, end of the glaciers. We call it as a terminus of glacier, where it deposits a recessional moraines at the end of the glacier. Okay, this is the area where the glacier is ending. So at when this the glacier completely retreat, it completely remove the water from here, then earlier this glacier was coming up to this, but now what you see in the photograph, the glacier is only up to this. So these are all the deposits which are produced by the glacier. So these deposits we call it as a ground moraines or the terminal moraines. Okay, so these are all stabilized. If it is stabilized or unstabilized, based on that there are different terminologies what we use. And finally all this water from the glacier, what will happen to that? That water will melt and it will go into the downward direction, and it will be contributing to some rivers. So that we call it as a outwash. Right? So these are the moraines. Moraines are unsorted and unlayered debris deposited by the glacier. Then we have the next category, we call it as, there are a number of features such as drumlines, eskers, and outwash plains and kettles. So drumlines are large deposits of glaciers and which long axes are parallel to the direction of the movement of the ice. So these are the large deposits. Usually it deposits in groups. So 2 or 3 deposits which are depositing in the direction parallel to the direction of the movement of the glacial ice. We call it as a drumlines. Eskers are narrow long ridges. So these are the narrow long ridges which are produced by the glacier deposits. We call it as eskers. Outwash plains are the irregular stratified fluvial glacier deposits. So as a result of the water which is transporting from the glacier, melting from the glacier, it will be taking the small grains from this part and it will be depositing in this part. So this portion where it will be a mixture of glacial sediments reworked by a fluvial. So this is a fluvial system or a river system. So sediments which are originated by glaciers now reworked by fluvial, we call it as a glaciofluvial deposits, or we call it as a outwash deposits. Okay, so outwash deposits which forms alluvial plains. If you remember, that was a plain land produced by the river. Here we call it as an outwash plain because the origin of the sediment is from glacial, and the water is also originating from the melting of the melting of the glacial. So kettles are small depressions which produced by the deposition of sediments by glaciers. Okay, so these are the main morphological features which produced by a glacier.